So welcome back to our notes for transformations of functions. We're working in example 2, where we're asked to write the equation for each of these graphs. Okay, in example A, we can see this hyperbola shape, which means our parent graph is a rational function. And the equation for a rational function, if you recall, is 1 over x. Okay, in the parent graph, the asymptotes intersect at the origin at 0, 0. The horizontal asymptote is along the x-axis, and the vertical asymptote is along the y-axis. In this transformed hyperbola, the asymptotes are going to intersect halfway between these two anchor points. So we can see 4 and 2, halfway between 4 and 2 is 3. And so the vertical asymptote is going to be along this line where x equals 3. Then halfway between the y-coordinates, -5 and -3 is -4. So the horizontal asymptote is the horizontal line along the equation y equals -4. So those asymptotes are intersecting at the point -3, -4. And that, remember, is with respect to the parent graph, which the asymptotes intersect at the origin. So to get from here at 0, 0 to here at -3, -4, we had to have rigid transformations that moved that intersection of asymptotes right 3 and down 4. And that is represented in the equation by the h and the k. Moving right 3 means that the h is +3. Moving down 4 makes the k a -4. Okay. The parent graph has its anchor points in the at 1, 1 and -1, -1 in these same positions, which means there's been no reflection. So no reflection tells me that my a and my b are both positive. And then when we look at the slope from this intersection of the asymptotes to that anchor point, we go up 1 to the right 1, down 1 to the left 1. Since that slope is 1, that tells me that there's been no dilation. So A is 1 and B is also 1, and there are no non-rigid transformations, so no dilations. When we put that information together in the equation here for transformation form, okay, the standard form for the transformation form would be if our parent graph was f of x is equal to 1 over x, then the transformation form would be f of, and then h is 3, so x minus 3. And the k is -4, so that would be plus a -4 or -4. Right? That would be the transformation form. To write the equation, when f of x is 1 over x, that would look like y is equal to 1 over, and then x minus h, which is 3, and then the k gets tacked on the end here with a -4. And that would be the equation that produces this graph. So to check that that is in fact the equation, we're going to go ahead and grab the graphing calculator and take a look at what this graph looks like as compared to example A. So in the y equals, I'm going to go ahead and type this equation that I just came up with. Since the denominator is a binomial, I need to group that denominator in parentheses. So 1 divided by the quantity x minus 3, and then close the parentheses on the denominator, and then my k is a -4. I'm going to change my window dimensions by pressing this window button, and then using this given graph as a guide. My x minimum, my lowest x value in this picture is -1, so I'm going to just tack 1 onto that and make it a -2. Okay, my x maximum in this picture is 6. I'm going to add 1 more and get 7. X scale, my x's are going by 1s, so I'm going to leave that a 1. My y minimum, the lowest point on this graph, is down here at -5, So I'm going to put another 1 on there and get -6. My y maximum is up here at +1, so I'll add 1 and get 2, and then the y scale is going by 1s, so I'm going to leave that alone and click on graph. So it's a little difficult to tell whether this hyperbola that we see in the graph is exactly the same hyperbola as what we see in A. So to test that it is in fact the same, I'm going to press this button that says trace, and trace lets me type in a value for x, so I'm going to type in 4, and when I press enter, I'm hoping to see -3 because the point 4, -3 was on my original graph. So I press enter, and sure enough, there's my point 4, -3. If I type in 2, again, here's my given point 2, -5, so when I type enter, I want to see a -5, and I do. So that point 2, -5 is on this hyperbola. And now I know that my equation does in fact produce this graph. So I'd like you to pause the video then and go ahead and try example B on your own, and when you're ready to come check your answers, go ahead and resume. Okay, welcome back. Hopefully you had a chance to go ahead and try example B. When we look at this shape of this graph, it's a sideways wiggle, and so we know that the type of function that we're dealing with is a cube root function. Okay, then the cube root parent graph, it goes through the anchor points 0, 0, 1, 1, and -1, -1. So instead of starting at the origin, this sideways wiggle is centered at the point -1, -3. So to go from 0, 0 to that new center point, I had to go down 3 and to the left 1. So I have rigid transformations that are left 1 and down 3. That tells me the the H and the K. So H, since we went to the left, is a -1. And then K, because we went down, is a -3. Okay. Now when I look at the position of this graph as compared to the parent graph, my slope is from the center to the next point up 2 and over 1, down 2 and to the left 1. So there's been no reflection, which tells me that my A and B are both positive. However, there has been a vertical stretch, because again, the parent graph would go up 1 over 1, but this graph is going up 2 over 1. And so that's a vertical stretch, which means my A is a +2. Okay, the B, since there's no reflection or horizontal stretch or shrink, we're going to go ahead and make that a 1, and then we can write our no reflection under rigid, and non-rigid there is a vertical stretch of 2, right, which is why the A there is a +2. So when I put that information together with my parent function f of x, the parent was the cube root, oops, let's fix that, equals, doesn't look very much like an equals. Okay, so I had f of x is equal to the cube root of x. That was my parent graph. So when I use this transformation notation, the standard form would look like the 2 in the front for the A, followed by f, my function, of the quantity x, and then minus a -1 would be +1, and then my k would be plus -3 or -3. Okay, that's my function notation. Now I'm going to go ahead and put that together to write the equation of this graph, which is y equals, and then my 2 out front, cube root, so the 3, the index of that radical goes in the hook, so 2 cube root of the quantity x plus 1, and then on the outside my k is a -3. Okay, and we're going to go ahead and check that using the graphing calculator. And if we go back to that y equals, we can hit clear to get rid of example A, and then we'll type in our new equation, which is 2, and then the cube root we find in the math menu. So we're going to hit math, and then arrow down to number 4, which is the cube root, and press enter. Okay, the tiny little 3 there is easy to confuse you have to remember, because you grabbed the cube root notation, this is not saying 2 to the third power, it's saying 2 times the cube root of, and then the quantity x plus 1 is going to go under the radical. We use the arrow to get out from under the radical, and then we can type the k, which is minus 3. Okay, I'm going to go to the window and adjust the dimensions of this window to match the graph that I was given. And my x minimum is over here, let's see, -4, -5. Okay, then my x maximum is at a 3, so I'll go ahead and add 1, make that a 4. My scale is going by 1s in the x direction. Y minimum is down here at -6, so I'll go down 1 more to -7. Y maximum is up here around 1, so I'm going to hit a 2, and my y scale is going by 1s. So when I hit graph, right there's my picture, and I'm going to hit trace now to type in some x values and make sure that the y's match. So if I put in a 0, I want to get back a -1, and sure enough I do. So the point 0, -1 is on that graph. When I type in -1 for my x, I want, when I hit enter, to get -3. So I press enter, and then -3 comes up for my y, so that's also on the graph. I want to see the point -2, -5, so I type in -2, press enter, there's the -5 that goes with it, and so I know that this checked. Okay, so I'd like you to pause the video one more time, and on some scratch paper, go ahead and try to write the equation for these two graphs. And when you're ready, go ahead and resume the video, and we'll go over these together. Okay, so welcome back, and if you've had a chance now to try these two examples writing the equation, we'll see that this first one, it's opening down, so there's been a reflection in the x-axis, so the a is negative. No change in slope though, it's still 1/1, so a is -1. The vertex, instead of it being at 0, 0, is at 2, 1, so we had a translation to the right 2, which makes the h a +2, and up 1, which makes the k a +1. And so the function form would be -f of the quantity x minus 2 plus 1, or in the equation form, to check it in the calculator, you'd have negative quantity, the absolute value of x minus 2, that plus 1. Okay, when you compare that to the next picture, both of them have their vertex at the same place, both of them are opening down. The only difference between this first graph and the second is the slope from the vertex to the one point to the right and left of that vertex. So now instead of going down and to the right one, we go down 2 and to the right one, which means the a is a -2 instead of -1. Okay, so there's the function form and the equation form, and hopefully you did well with those two checkpoint problems.